All right, good morning, everyone. Gonna try to make this video quick. I kind of pre-filled some stuff in already, um, and hopefully I don't get interrupted here. I am gone from school today due to some sick children at home, so gonna try to be quick and get what you need here so you can fill in the notes. So 3-3, we start using that the synthetic division to actually find the real zeros for bigger polynomials. So rational zeros theorem just says if we have a polynomial, p of x, and it could be any kind of polynomial, if it has integer coefficients, then every rational zero is in the form p over q. So you probably remember hearing about p's and q's in algebra 2. So p is all the factors of the constant term, okay, and q is all the factors of the leading coefficient. Okay, and just review, constant term is the number that doesn't have a variable, and the leading coefficient is the number with the biggest exponent. So if you look down at number 1, zoom out so you can kind of fill this in. The p's are coming from the constant, which is 2, and the q's are coming from our leading coefficient, and in this problem the leading coefficient's 1. So all the factors of 2 are 1 or -1, 2 or -2. So that's how we put the plus or minus there. And then the factors for 1, because just a reminder, there is a 1 in front of the x to the third. The only thing you can divide 1 by evenly is 1 or -1. So that's where we get our p's and our q's from. The factors of the constant and the factors of the leading coefficient, and we will put plus or minus because it could be positive or negative. So now if we make a fraction with p over q, what we would start with is 1 over 1, which would give us 1, and then we would do 2 over 1, and 2 over 1 is 2. So the possible zeros, okay, just to point out, these are the possible zeros. They're 1, -1, 2, or -2. Okay, so we want to find all the rational zeros, and these are the only possible rational zeros. What we're going to do is test each of these possible zeros and see which ones give us 0 using synthetic division. So we're going to set this up. And whenever we do synthetic division, we do have a placeholder here. We have 0x squared. So it's going to be 1, 0, -3, and 2. Okay, and first we're going to test 1, and we're going to set the exact same thing up. I'm going to test -1, and we'll set the exact same thing up and test -2. And we can set it up and test +2. Okay, so this is one way you can do it. I'm going to show it this way. There actually is a shorter way, or kind of a shortcut. So if we did this way, we'd bring down the 1. 1 times 1 is 1. Add those up, we get 1. 1 times 1 is 1. Add those up, you get -2. And 1 times -2 is -2. So this one does give us a 0. So yes, 1 is a 0. And then we test -1. Bring down the 1. -1 times 1 is -1. Add them up, you get -1. -1 times -1 is +1. Add them up, you would get -2. -2 times -1 is +2. Add them up, you would get 4. 4 is not 0, so that's not a 0. I'm going to scroll down, bring down the 1. 1 times 1, -2 times 1 is -2. Add them up. -2 times -2 is +4. Add them up and we get 1. -2 times 1 is -2. Add them up and we get 0. So yes, -2 is a 0. Okay, and the last one, bring down the 1. 2 times 1 is 2. Add them up, we get 2. 2 times 2 is 4. Add them up, we get 1. 2 times 1 is 2. Add them up, we get 4. So this one is not a 0. So the zeros we have right here are 1 and -2. Okay, the shortcut I could have showed you, I'll show you right now. You don't have to write this down if you choose not to. But when you get a 0, so we could either pick this one gave us a 0 or this one gave us a 0. So when you get a 0, you could rewrite your answer. So this would be 1x squared minus 2x plus 1. And we could actually factor this now. This would factor out to x minus 1, x minus 1. And then when would x minus 1 give you 0? When x equals 1. So this was one of our zeros. The other 0 was the number we got when we did synthetic division. So once you get a 0, you can actually factor to find the other zeros, which is what we're going to talk about, I believe, right here. So factoring and finding the rational zeros of a polynomial. First, we're going to list all the possible zeros. We will use synthetic division to evaluate possible zeros. And when we get a remainder of 0, we're going to use the quotient that we obtained. So use the answer we get. And then we're going to repeat steps 1 and 2 for the quotient. And we're going to stop when we get something that we can factor easily. So like in the problem above, we could have stopped and factored that right away and got our zeros instead of plugging them in over and over again and testing all of them. So list the zeros, do synthetic division, and find one that gives you a 0. And then from there you can factor. Yep, so we'll flip over it. We have a couple examples on that in the next page. So if you look at the number 1 on the next page here, and if I'm going too fast, by all means, you can pause whenever you need. If I'm going too slow, you can speed it up in ×1.5 or ×2 speed. Use the rational zeros theorem to factor the polynomial. So we're going to factor this. We're not finding zeros, we're factoring. So I already listed the possible zeros, the possible p's and q's. So the p's and the q's are listed. Just a reminder that the p's are coming from 6, our constant. And the q's are coming, in this case, they're coming from 2, the leading coefficient. So what can you divide 2 by? 1, -1, 2, -2. All right, so down here, if we list all the p's over q's, if we first do 1 over 1, that would give us 1. And then we do 1 over 2. Okay, and then we move down to the next one, right here, which would be 2. 2 over 1 is 2. If we did 2 divided by 2, you would get 1 when we already listed 1. So we don't have to list it again. So we go to 3 over 1, which is 3, and then 3 over 2, which is 3 over 2. Okay, and then we move on to 6. 6 over 1 is 6. Okay, and again now, what is 6 over 2? 6 over 2 is 3. We already listed 3, so we don't have to list 3 again. So these are all of our possible rational zeros. Okay, so our list is longer here. So what we're going to do is I'm going to start by choosing the easy ones. You want to make a little note there. Choose easy ones. What I mean is I'm not going to pick 1/2 and 3 over 2 until I have to, because those numbers aren't easy to work with. So there's kind of a shortcut to writing this. You don't have to like write a box over and over and over again. Okay, so I'm going to do a little differently than I did the front page. Okay, I'm going to set this up kind of with 2 lines. The coefficients are going to go above that line. So the coefficients, if you look over here, are 2, 1, -13, and 6. Okay, there's no placeholder. So we're going to put 2, 1, -13, and 6 above the line. Okay, and then all of these possible rational zeros that we want to test, we're going to put them on the left. Okay, and again, we're going to start with the easy one. So I'm going to start with 1 and -1. So we're going to do the same synthetic division. We're going to bring down the first number. Okay, and now we're going to think, what is 1 times 2? Give me this. 1 times 2 is 2, and then you just add this to our next number. So 1 times 2 is 2. We add it to 1. 2 plus 1 is 3. Okay, and then we do 1 times 3. We get 3. Then you add 3 to your next number. 3 plus -13 is -10. Okay, 1 times -10 is -10. -10 plus 6 is -4. You can write that down, but you don't really have to, because once you know it's not 0, we are going to cross it out and go to our next number, which I'm going to use -1. So we bring down the 2. -1 times 2 is -2. -2 plus 1 is -1. -1 times -1 is 1. 1 plus -13 is -12. Okay, -1 times -12 is 12. We know when we add that to 6, it's not going to be 0, so we just cross it out. Now the next possible zeros I'm going to pick, I'm not going to pick 1/2. I'm going to pick 2 or -2, because those are easier numbers. So we bring down the 2. 2 times 2 is 2. 2 plus 1 is 3. 2 times 3 is 6. Actually, I added that up wrong. I just realized. 2 times 2 is 4, and 4 plus 1 is 5. Good thing I caught that, because that would have screwed up the problem. Again, 2 times 2, 4. 4 plus 1 is 5. Now 2 times 5 is 10. 10 plus -13 is -3. And 2 times -3 is -6. And -6 plus 6 is 0. So this one gives us a 0. Okay, so now we rewrite our equation. Okay, the biggest exponent in our problem, if we look back here, was 3. So this answer right here is going to be 2x to the second plus 5x minus 3. Because we always go one exponent lower. Okay, and now we check, can we factor this? 2x times x is 2x squared. So now numbers that multiply to 3. We could try 3 and 1, the only ones that work. So if we do it in those spots, 2 times 3 is 6, and 1 times x is 1x. If we make this a positive 6x and a negative 1, 6 plus -1 is 5. And then we just check, what is -1 times positive 3? It is -3. So that does work. So we're able to factor that. So now in our answer, we do need to bring down the number we used here. So if 2 gave us a 0, how would you write that in factored form? Well, if we brought that down, positive 2 gives us 0. That means x minus 2 is the factored form, because 2 minus 2 gives us 0. So this would mean 2 would give you a 0. Okay, and then we also have 2x minus 1, and we have x plus 3. Okay, so this problem just said to factor, so we're done there. Okay, if the directions ever say find all the zeros, well then we'd have to actually figure out what the zeros are. Okay? So going down to the next example on this page, we're trying to find all of the real, rational, actually the real zeros here, not the rational, the real zeros. So I already listed all the p's, all the q's. Okay. So if we did p over q now, 1 over 1 is 1, 2 over 1 is 2, 5 over 1 is 5, and 10 over 1 is 10. Okay, so that was quick to find p over q. Now we're going to set this up the same way above with that box. It does not look like there are any placeholders, because we're not missing anything here. It's fourth power, third power, second power, first power, and so on. So the coefficients are 1, -5, -5, 23, and 10. So over here, we're going to draw our box. Okay, we're going to put 1, -5, -5, 23, and 10. And we're going to start with the easier numbers. The easiest numbers I would say are 1 and -1. Okay, so we bring down the 1. 1 times 1 is 1. Add it up, we get -4. 1 times -4 is -4. Add it up, we get -9. 1 times -9 is -9. Add that up, we get 14. 1 times 14 plus 10 is not going to give us a 0. So move to the next line. Bring down the 1. -1 times 1 is -1. Add it up, you get -6. -1 times -6 is 6. Add it up, you get 1. -1 times 1 is -1. Add it up, you get 22. And then right here, if you notice, -1 times 22 plus 10 is not going to give us a 0. So go ahead and try 2, because 2 and -2 also are possible zeros. So bring down the 1. 2 times 1 is 2, plus -5 is -3. 2 times -3 is -6, plus -5 is -11. 2 times -11 is -22. Right, 2 times -11 is -22, plus 23 is 1. And 2 times 1 is 2, plus 10 is not going to give us a 0. Okay, so try the next one. Bring down the 1. -2 times 1 is -2. Add -5, you get -7. -2 times -7 is 14. Add -5, you get 9. Positive 14 plus -5 is 9. -2 times 9 is -18. Add 23, you would get 5. -2 times 5 is -10. When you add 10, you would get 0. Okay, so we get 0. This is one of our zeros. Okay, now we check. If you write this answer out, our biggest exponent was the 4th power. So this answer, if you wrote it, would be x to the 4th minus 7x to the 3rd. Sorry, excuse me on that. Not x to the 4th. It'd be one smaller than that. So it's x to the 3rd minus 7x squared plus 9x plus 5. And we could try to do grouping here, because it is 4 terms. Grouping is not going to work. Okay, so what we're going to do now is actually take this and we're going to rewrite our coefficients above here, our new coefficients, and we're going to go with our possible zeros on the left side. So we already checked 1, -1. We already checked 2 and -2. So now we have to check 5 and -5. So if you put 5 there, bring down the 1. 1 times 5 is 5, plus -7 is -2. 5 times -2 is -10, plus 9 is -1. 5 times -1 is -5, plus 5 is 0. So 5 gives us a 0. And now this answer is written as x squared minus 7x. Sorry. Making a bunch of mistakes here. Minus 2x minus 1. All right, we can try to factor this. It's kind of a long problem. X times x is x squared. So now to get -1, we know that we need 1 and -1. The issue is this is not going to add up to -2. So this is not factorable. So what we're going to do, since we can't factor it, we will use quadratic formula. Okay, so x equals -b plus or minus the square root of b squared minus 4ac all over 2a. So we write this out. The opposite of b is positive 2 plus or minus the square root of -2 squared, that's our b squared, minus 4 times a times c, and our c value is -1. all over 2 times a. All right, so if we do some algebra here, it's 2 plus or minus the square root of 8 all over 2. Right, 4 minus negative 4 is 8. And then when we simplify this, change colors, the square root of 8 is really square root of 4 square root 2. So this becomes 2 plus or minus 2 root 2 all over 2. Right, because this over here, square root of 4 is 2, so it's 2 root 2. And then all of these 2's for all these terms can be reduced, can be divided by 2. So we end up with 1, oh no, we end up with 1 plus or minus square root of 2. Okay, remember this was 2, turn it, 2 plus or minus square root of 8 all over 2, and then we got 2 plus or minus 2 root 2 over 2. When you reduce that, it's 1 plus or minus square root of 2. So all of our zeros, if we list them, are negative 2, positive 5, and then 1 plus or minus square root of 2. Okay, I'm going to stop here. I will make a shorter video on Descartes' rule because I can hear that I have some things to attend to with the kids here in the next door before I get interrupted. So there's that. I'll make the Descartes' rule video, and then that'll be it.